Hello, I'm Jacques Richer,
And I'm Riley Tukey.
and this is the Making in Progress podcast by the Rossum Rumblers Robotics Club
At ASU Poly.
Dur, 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 dur.
I hope you didn't just shoot that whole thing out.
And today we're going to be talking about logic analyzers. A logic analyzer is a device like this one that is used to eavesdrop on signals between one digital device and another digital device when you're trying to figure out why the first digital device is not really talking properly to the second digital device.
Or also in the case of reverse engineering. So if you've got a product and you want to know how its chips are talking to each other, use logic analyzer.
Typically, in order to do that, what you do is you take a board and you instrument it by attaching probe wires to various parts of the board. And then what you do is you take your probe connectors and you attach them to the probe wires. In this case, we have a device made by an undisclosed manufacturer, and we were doing some reverse engineering earlier this evening. It turns out that what this particular device does is use RF, that's radio frequency, to communicate between this device, which is a handheld unit, and a base station device that's attached to a
PC
client
or laptop.
PC or laptop. It uses a Nordic RF chipset, the NRF 24L01 Plus. That's a 2.4 gigahertz radio. Now we wanted to figure out what was going on with the format this device is using to communicate with the base station device. So what we did is attach some probes to it, and we were watching on a laptop screen to see what those signals were. The other thing we did this evening was use a similar device to talk to this device here, which is a small programmable non-volatile memory,
Often called a PROM or an E-squared PROM.
or an I-squared PROM. In this case, it uses SPI, which is the Serial Peripheral Interconnect protocol, to communicate between the microcontroller, which is the brains of the operation, and this PROM. And essentially, it says, store this byte at this location, or store these bytes at this location.
Or I want this one.
Or I want the bytes at these locations. And by monitoring the bus, you can see how it's using the data.
And it's not volatile, meaning when the device is powered off, it holds its memory.
Logic analyzers are among the most useful tools when you're doing embedded development, which is to say, developing the software that runs on some widget rather than software that operates on a general purpose computer like a laptop or a desktop machine or something.
Or even some high-powered microcontrollers.
Yeah. Things like Raspberry Pi, for example, are pretty much above the level where you'd consider them embedded. Like
Yeah.
cell phones and stuff like that
That's all above
are
embedded for sure.
sort of above the line.
Would you consider the Wi-Fi above the line? Or is that still...
You know, that's a really interesting device. Microchip recently came up with a Wi-Fi device. It's part of their development board series.
the chip kit?
Yeah, the chip kit development board series, and that runs at 200 megahertz?
Yep, 200 megahertz stock clock.
And that's a 32-bit. I think that would be pretty much at the line. Above the line, above that, you start getting into things that have...
Actual like Linux-based operating systems on them. Usually the BeagleBone's a good example.
Yeah, the BeagleBone, the Raspberry Pi, the QB Truck. Devices like that have a little bit more oompah music. You can run a real operating system on them as opposed to a cut-down real-time operating system. You can run a real debugger on the device.
Yeah.
You can run a compiler on the device. That's usually my cutoff line.
Is when you
If I
run a
can
compiler.
run dev tools on the device itself,
Then it's no longer an embedded.
then it's no longer an embedded platform, or at least it's not a classic embedded platform. I think we're going to see a lot more stuff at the high end as time goes on,
yeah.
just because of cost reductions. But getting back to logic analyzers, the value in them is that you can look at the signal and look at the response. And a lot of times you write your code, you run it, you're thinking it sends signal A on the wire. And you look at the wire and that's not at all what went out. And of course you get back a response that makes no sense whatsoever. But you look at the wires and it's like, it would really, really help if I use the chip select.
Yeah.
It would help if the chip select was actually doing something, or one of the classics. I had one of the microcontroller pins providing power to the device, and in my code I forgot to put the power on.
Yeah, that's usually a problem.
And that caused it to do the serious case of not functioning. It did a superb case of not functioning. Now, you might think that such a device would be, fairly expensive, but this particular logic analyzer, which is a clone of a popular logic analyzer, can be gotten from China for as little as $10 to $15. And there's a really nice open source project, SIGROK, S-I-G-R-O-K. You can get the information on it from sigrok.org, sigrok.org, that provides the software to make this work for free. And using a combination of cheap hardware and free software, you can have a basic set of tools that will do the usual jobs, the usual protocols.
Allow you to do basic debugging on a lot of your conventional microcontroller applications. If you've got an Arduino with an SPI bus and you're wondering why it's not working.
If you've got a BeagleBone Black,
That's good.
or especially some of the BeagleBone Black stuff, some of the Raspberry stuff.
More.
Yeah, well, the thing is, when you get into the Raspberry projects, into the BeagleBone Black projects, that's where it really comes in handy, because
You have the processing power to be shifting that much data, and so usually you're going to have a peripheral connected to it that needs that.
and
So
the
you're going
other
to need to debug it.
and the other thing is, when you have more processing power, you tend to do more demanding projects,
Yeah.
because you've got it.
Why not use it?
Well, that's about all for this segment. And we'll see you guys again next week. We are lost. My name is Jacques,
And I'm Riley.
and we thank you for listening to our podcast, Making in Progress.
This podcast brought to you by the Rossum Rumblers Robotics Club at the ASU Polytechnic campus.
If you wish to learn more, please visit us on Facebook at
Facebook.com/Rossum Rumblers.